Okay, so I want to talk a little bit about the test. The test is going to be 30 multiple choice, and they're going to be worth 2 points each. And then there are 5 problems for the remainder of the 40 points. You know you're going to have a Doppler, at least one. You know that there's going to be open pipe or fixed stream kind of problems, same thing. Same equation, same mathematical relationship. Then there'll be a closed pipe. And remember that a closed pipe will only form odd harmonics. Okay, machine, please don't act up. Only form odd harmonics. Oops, that's goofy looking. Odd harmonics. 1, 3, 5, and 7, and so on. And that has to do with the geometry of the situation. We have to have it closed at one end and open at the other end. So there is a node here, an antinode at this end, so it's going to make something like that appear. So that's a quarter of a wavelength. So the next one has to have, that next one I could form would have to have a node at one end and an antinode at the open end, and that would be 3/4 of a wavelength, and so on. So that's my first, and then I get my third and my fifth harmonics. You can go back and look at your notes if you're not real clear about what she's talking about. The equation for this one is F is equal to NB over 2L, where N is the harmonic number. And then for the pipe that is closed at one end, it's F is equal to NB over 4L. And N is still the harmonic number. Remember that we've talked about frequency, and that's the cycles per second, which is hertz. And we've talked about period, which is the time for one cycle. So this is measured in seconds, and they're related by T is equal to 1 over F. All right. You need to go back over those definitions that were on the list of vocab terms. Know what transverse waves are, mechanical waves, longitudinal, compressional waves, rarefactions, compressions, what is the function of a wave. All of that vocabulary that we did would be so good to know. And you need to be able to talk about the fact that the distance from crest to crest is a wavelength, lambda. That was on that the vocab quiz also. And you need to know that sound is a longitudinal wave. Again, right off that vocab quiz. We have interference that occurs. We can have constructive and destructive interference. So if they meet in phase, meaning crest meets crest or trough meets trough, we're going to get constructive interference, and our sound is going to be amplified. If they move out of phase, meaning a crest meets a trough, that's going to be destructive interference, and we're going to have a decrease in our sound. It could cancel out completely and give us silence. There's really no way of knowing unless we know the size of the crest and the trough, but we do know that its destructive interference will cause a decrease in the volume. Be able to think about the Doppler, not just calculate it, but think about what it actually means, and the best way to think about it is if you're standing still and the sound is coming towards you, the distance between you and the sound is getting shorter and shorter as it approaches you. So if it gets shorter and shorter, then there's less distance for the wavelengths to be formed, so the wavelengths appear to get shorter and shorter, and my pitch appears to get higher. Once it leaves me, the distance between myself and the sound source is getting greater and greater. So my wavelength increases, and it appears that the sound has a lower frequency. Let's see. Know your definitions. Remember that when you do the Doppler, we said that plus meant toward, and away went. If it's moving away, we make it minus. So the way that looks in the equation is that f prime is equal to f naught v plus v naught over b minus v sub s. Be careful, these do not, leave those in there, and then what I do is when I'm looking at the observer, that's where I put my positive 10 if it's going toward the source. And then this right here is where I put my negative. So then I don't make the algebra mistakes that are so easy to make. So be careful. This was originally a positive and it needs to stay a positive, and this needs to stay a negative, and then the sign change comes with this quantity v sub s and v sub naught, observer and source of the sound. Okay? Realize that the speed of sound changes by 0.6 meters per second for every degree Celsius rise in temperature. Let's see. You know, when we did the standing wave lab, that you were asked to measure the amplitude. So if this was your vibrating standing wave, that looks pretty nice for me. I'm usually not very good at drawing these. Oops, there we go. This distance from here to here is the amplitude. It is not that distance. It's only from rest position to the farthest displacement. So be careful. That's your amplitude. All right. Know that your fundamental sound is your first harmonic. Your second harmonic vibrates at 2 times the fundamental, and f sub 1 is the fundamental. The second harmonic is also called the first overtone. So then that means that the third harmonic vibrates at 3 times the fundamental, and it's called the second overtone. To be an overtone, you have to be a multiple of the fundamental. To be an overtone, you have to be a multiple of the fundamental. Let's see. Oh, I know what I was going to talk about. When you draw a standing wave, make sure that you can identify the nodes. And the antinodes, these regions here, maximum displacement, and this is my position of equilibrium or rest. Know that students, our hearing can be in the range of 20 hertz to 20,000 hertz. Anything beyond 20,000 hertz is called ultrasonic. Anything less than 20 hertz is infrasonic. Think about the lab that we did with the water. You had the tube. It was either PVC or a golf tube. It was closed at one end and there was water right there. And then you said that you caused resonance to occur in this tube. So you excited the air inside this tube and it formed a fourth of a wavelength because it was closed at one end. So when you went to find the wavelength, you had to take the length of the corrected length of the vibrating tube of air and multiply it by 4, and that's where the lambda came from. So let's go back and look at what I told you about the problems. I told you you'd have a Doppler for sure. There will be open pipe and closed pipe. There will be an opportunity to talk about the fundamental. If I give you the fundamental is 320 and I ask you to find the second harmonic and it's an open pipe, then you're going to say 320 times 2. If I ask you for the third harmonic, you would tell me 320 times 3. But if I said to you the fundamental of a closed pipe is 320, then you would multiply by 3 to get the second harmonic. So the second harmonic in this case would be 960 hertz. I'm sorry, I shouldn't call it, I should have, what a dork. I should not have called that the second harmonic. That was actually the third harmonic because it's closed. We only get the odds, so this should be the third. My bad. And then if I wanted the next one, it would be the fifth because I'm only going to get the odds. So that would vibrate at 1600 hertz. Is the fifth harmonic. And I would say that it's also possible that I would give you some harmonics. Maybe I would give you 225. And I would call that the fundamental. And I would say that the pipe then is known to vibrate at 675. And then again at 1125. Sorry, this is not cooperating. 1125. And I would ask you whether that would be a pipe that was open or closed, if those were the three that I could detect. And so you would tell me, well, 225 divided into 675 is 3, and 225 divided into 1125 is 5. So I have 1, 3, and 5, so my pipe is closed at one end. So I think those are the kinds of things that will help you prepare for the test. Know your vocab, read over your notes, and look at those problems in the review worksheet that you were given. Great place to start. Good luck.